Okay, we've got Cement Canada joining us today. Would you care to introduce yourselves?
Okay, my name is Roy Slack, and I'm president of Cementation Canada.
And I'm Alan Price-Jones. I'm technical director of Cementation Canada.
Okay, what would an elevator pitch for Cement Canada's injection hoisting system sound like?
Well, we're still working on that pitch because that's the pitch we need to give at the Disrupt Mining competition. But in a nutshell, we're going to be talking about briefly about the technical aspects of the innovation, and then how it's going to impact mining, and both in terms of cost, productivity, safety, conservation of energy. There's a number of factors that come into play there, but we have all of this to do in about 5 minutes. So we're still working on that pitch, Heidi, but by the time we get to the conference, we'll be ready.
Of course. Yeah. Could you explain a bit about how this system would eliminate the need for mine shaft production hoisting or trucking?
Yeah, the system is an improvement on previous attempts at moving mine product, like the rock material, from great depths of about 2,000 feet up to surface using a pipeline system. And the rock material is blended with a slurry, and it's transported to surface by using a fluid to pipeline loop. So clean fluid goes down the loop, the rock is charged or injected into the system at the bottom, and the injection material then rises up to the surface, up the other leg of the loop. Hence the term injection hoisting. We're hoisting the rock from deep down up to surface.
So what you asked about, Heidi, traditionally what we do now in mining is either large trucks, 30, 40, 50-ton trucks, drive that rock to surface, or quite a large hoisting plant lifts it up in what we call skips or containers. And this system would eliminate the need for either of those. It would move the rock up through the pipe, as Alan described. So.
Okay, this is a question I got from my audience. How does the injection hoisting system address concerns that mining operations may be inefficient, unsafe, or environmentally unsustainable?
Well, that's a loaded question for sure. And of course, we're involved in the mining industry, and from our perspective, we're in a safe industry. We're in a technologically advanced industry. This innovation is an improvement. So I think in terms of energy efficiency, we will reduce the amount of energy required. In terms of footprint on surface, we see that this could take a smaller footprint for some of the big installations on surface. By eliminating trucking, of course, trucks operate with diesel, which many vehicles do. The fewer vehicles we have on the road, whether it's underground or on surface, the less CO2. So there's some positives for the environment as well. I don't know, Alan, if you want to add to that.
Yeah, the system itself would require very little in the way of human operators. Every truck has a truck driver, and so apart from the time involvement there with the injection system, there would be maintenance of the system, but there wouldn't be individuals required to move every batch. Each truck might be 30 or 50 tons, and this is a system that is running as a continuous process.
Okay, what do you expect out of the Shark Tank format? And if you receive some of the money, how would you invest it?
Well, I think what we've already seen, the announcement was yesterday. What we've already seen is quite a bit of interest from the industry. So right away from this Disrupt Mining and this Shark Tank event, there's going to be a lot of interest generated from mining companies in this technology. So that's great. That's the first thing that's going to happen. If we do get some funding, that would go to building the prototype. The next step in our process is building a full-scale prototype system, which would be in a mine somewhere in North America. And we would want to build that with probably with a mining company, because if we need to put it in a mine. So that money, if we were lucky enough to win that, would go towards the development of the prototype for the system.
Awesome. So that's all the questions I've got. Would you like to add anything?
Alan, do you want to?
Well, we're very optimistic about this system. It makes use of physics principles that are very well proven. Deep drilling uses the same principles to bring material up from very great depths, in excess of 2 or 3 kilometers depth. And so what we've done is that we've adapted these principles into a system where it's not been done this way before, and we've got great hopes for it being able to transform some of the mining aspects, not only moving much from great depths, but actually once you have the material in the form of a slurry, it can be delivered not just from the mine shaft at surface, it can actually go all the way into the next phase of any kind of process plant, and thus save quite a lot of rehandling of the same material over and over.
Awesome. Thanks for joining us.
Okay, well, thanks for the invitation, Heidi. We appreciate it.
Thank you very much.